Hello students, my name is Adebayo Motosho and today I'll be making a presentation in the context of secure software engineering titled Code Reuse Attack. First of all, these are the learning objectives. At the end of the presentation, students should be able to understand the concept of code reuse attack. They should also be able to compile gadgets from a program binary and have an understanding of how bash shell attack works. Code reuse attack is a special type of injection attack that works by chaining together small pieces of instructions called gadgets. Instead of injecting new instructions, an attacker selects small pieces of instructions from existing program code base to give a new command to a program. So technically, an attacker writes in the protected region of the memory. For example, in this simplified memory layout, an attacker has written beyond the bound of a 12-byte buffer variable. With the return address being overwritten, the program's control flow is hijacked and sequences of instructions not called by the original program in the code sections are being executed as malicious addresses are being popped from the stack. This kind of problem is prevalent in applications that have large C code base. For example, the operating systems, the databases, and embedded systems were largely written in C language, which has so many memory vulnerabilities that we can exploit to maliciously reuse code. So in order to demonstrate this attack, our tasks are to find the vulnerability such as the usage of unsafe C functions in a program because bound checkings are not usually performed by these functions, which makes them easy targets. Afterwards, find gadgets. Then link these gadgets together using the technique of overwriting return address. Craft a payload, then run an exploit. So these are some of the tools we're going to use for this demonstration. This is a vulnerable program that we're going to exploit. This program simply copies a string into a buffer of size 12. We will use the vulnerability in this program to launch a bash shell, which is equivalent to passing bin sh to system function. This is how the program is compiled using GCC. The next step is to compile the gadgets, which could serve as potential instructions for exploiting this program. This is how to call the rob gadget tool on our binary UCLAN. So these are the generated gadgets. A total of 92 gadgets were generated and we are selecting just 3 of these gadgets. Further instructions on the rules for selecting gadgets will be presented in the next section of this course. In the meantime, let us zoom in on the selected gadget. As we can see, our first gadget pops the address of system from the stack, but system needs an argument. It means that we must also pop the address of bin sh from the stack. Because the first argument of a function must be in register R0, therefore we pop the address of bin sh into R7, which will later move into R0 in the last gadget. This forces the system function to load whatever is in R0 as its parameter, which is the address of bin sh. This is how we can find the address of system and bin sh in GDB. Before showing the payload, it is worth mentioning that the addresses should be written backwards, a byte at a time. Now to the payload. Remember that our buffer is of size 12, but the return address of UCLAN is after the first 16 bytes. So we replace that return address with the address of gadget 1, followed by the address of system, then the address of gadget 2, then the 12-byte garbage to fill up the registers which are not part of our exploit, but are unfortunately part of the gadget we selected. So here we fill up register 4, register 5, and register 6 with the garbage. Then the address of bin sh in R7, another 12-byte garbage to fill up register R8, SB, and SL. Then the address of the third gadget, which calls the system function with the bin sh parameter in R0 and opens our terminal. Running the program uclan bash with our payload automatically launches the shell. The host computer is now breached and we can run several Linux commands, just like the real owner of the computer. So in the next session in this course, we will take an in-depth look on how to select and link gadgets and how we can bypass the credential checking by injecting existing code. Here are some additional learning resources. Thank you for listening.